Okay, for example 5, it says, find the dimensions of the largest possible rectangle that can be inscribed in a circle with a radius of 4 centimeters. So, we have a rectangle. It's inside of a circle. The radius is 4 centimeters, which means that the diameter, which is 2 times the radius, has to be a total of 8 centimeters. We also know that that is going to create a right angle triangle where for a rectangle we have one leg is going to be the length, the other leg is going to be the width. So we're going to let L be the length. We're going to let W be the width. And because it wants the largest possible rectangle, the size of the rectangle is going to be based on the area. And all of these have to be greater than 0. And the length and the width, because they're legs of that right angle triangle, have to be smaller than the hypotenuse of 8. Now, because we're going for the largest area, we're looking for the area maximum, and the area of this rectangle is going to be the length times the width. When we turn it into one variable, we're going to be doing it based on the fact that we know that that is a right angle triangle, which means that the length squared plus the width squared has to equal the diameter, the hypotenuse, 8 squared. Yes, 8 is also the diameter of the circle. Which means that the length squared is going to equal 8 squared, or 64, minus the width squared, which means that the length is going to equal the square root of 64 minus the width squared. And then I'm going to sub that back into the formula. The area is going to equal the square root of 64 minus the width squared multiplied by the width. We get to step 5 and we have to derive. We are going to use the product law. A prime of W is going to equal the W times, when I derive that, I'm going to think of it in terms of the width, and 64 minus W squared to the 1/2. So that when I'm deriving it, I'm just using that chain rule, and I'm going to say that it's going to be 1/2 the 64 minus W squared to the negative 1/2. And that's all going to be multiplied by negative 2W. And I'm going to add to that the 64 minus W squared to the 1/2 multiplied by The derivative of w is just 1. This is going to give me negative w squared times 64 minus w squared to the negative 1/2 combined with 64 minus w squared to the positive 1/2. Now I'm going to factor out that negative exponent, 64 minus w squared to the negative 1/2. And that's going to leave me with negative w squared and then plus 64 minus w squared to the power of 1. Which means what I'm really going to have is I can combine those negative w squareds, and I'm going to get 64 minus 2w squareds. And in the denominator, I have, when I move that negative exponent down, the square root of 64 minus w squared. Or I can factor the numerator and get 2 and 32 minus w squared, all divided by the square root of 64 minus w squared. Next, I'm going to go on to my critical numbers. And for my critical numbers, I'm going to look at the numerator and the denominator. For the numerator, if I have 32 minus w squared is equal to 0, then w squared is equal to 32, which means that w is equal to the positive or negative square root of 32. But wait a second, the width can't be negative, which means that that negative answer doesn't make sense. So the width is just going to be the positive square root of 32 because the width has to be greater than 0, or when I simplify it, the width is going to be equal to 4 root 2. From the denominator, I'm going to have the square root of 64 minus w squared is equal to 0. 64 minus w squared, when I square both sides, is equal to 0. W squared is equal to 64. And when I square root, I'm going to get 8, which does not work because it cannot be the same length as what the hypotenuse is, or the diameter of the circle is. It doesn't make sense because 0 is less than the width, which is less than 8. Which means that the only solution that works is the 4 root 2. I'm going to use that for my first derivative test. Zero, 4 root 2, and 8. I'm going to pick numbers that fit into here, like 1 and 7. And I know that it can't possibly exist out here or out here. Which means a prime of w, if I use 1, is positive. If I use 7, it is negative. Which means that my a of w is going to be increasing, then decreasing, and there is my max. So if my w is equal to 4 root 2, then that means that my length is equal to the square root of 64 minus 4 root 2 squared, which is going to be the same as 64 minus 32 in the radicand, or the square root of 32 in the radicand, which is still just going to be 4 root 2. The dimensions of the largest rectangle that can be inscribed in circle are 4 root 2 centimeters by 4 root 2 centimeters.